Hello and welcome back. We are on embedded system design on learning on ARM Cortex M4 programming series. If you haven't revised so far, please do go back and catch up with all the concepts and so you would be able to be use those peripherals and the registers that associated with that to connect to this programming. So it will be much helpful if you do that. Today we are on day 24. Today is the continuation from the last session, I2C part 1. Today is I2C part 2. Today I'm going to give a small recap of what we learned so far on the I2C, and then we'll proceed ahead to continue with our programming to write new functions about how the byte read is written. And there are two different burst modes. You need to write burst write and burst read. And then finally you need to write functions to interface with the ADXL345. So these are all the sections you will learn today. I'll brush through fastly so you can know what it is we learned so far. Before that, I'm giving a small introduction. I'm representing A2Digi. This is a startup by Anbukarasu brothers, my brother Alex and myself Arul in 2023. Both of us gathered over 20 plus years of industry experience, and we would really like to put it out there to you all so that it will also be beneficial to you to be a better professional. And our mission is to convey to at least to 100,000 of you future professionals through the form of online courses. And the main advantage of that is you can study and learn from anywhere, wherever you are. That's really good about it. A little bit about me. I'm Arul P. Anbukarasu. You can call me as Arul or API, as persistent as I would like to be, to share my knowledge and experience with you so that it be helpful for you. I have over 20 plus years of experience in various industries working in different countries in Australia, Italy, Singapore, and in India on these industries: renewable energy sector, converting solar and wind energy conversions, power systems related to lead acid batteries, network embedded systems that's linked to ATMs, TCRs, and POS, and smart banking automation systems, and smart parking operations. And my expertise lies on these three: embedded systems, VLSI, and project management. I got a small announcement to bring that to you. I have categorized into two different categories: YouTube viewers and internship professionals. All the videos recorded will be shared on our A2Digi YouTube channel. In order to be eligible to get a free certificate, you have to watch at least 28 videos. And at the end of every video, you'll have a short attendance link. So fill those details and send it across to us, and that will be eligible for your e-certificate. Part of YouTube regulations, the videos can't be there forever. So it has to be removed after 2 or 3 days. So if you miss out any session and if you want to go back, you simply miss out. So for that, I would highly recommend you and advise you, please join our internship program. And that will achieve you to not only get your internship certificate, when you land into that first interview or first job, your senior engineers will always consider this 32 days of your learning will be really high up there, because you already went through and learned all the fundamentals of it, and you got your hands on in developing projects. So use those skills and the learned thing and use that in the real industry as well. So it is really beneficial. You will also get your own separate login. You can log into our LMS portal and you can go through the session, each and every session. And if you finish, when you click the button, complete button, that will count as your attendance for that day. Not only that, you will get unlimited access to all our PDF materials, the source codes, the reference manual, the data sheet, the schematics, everything what you need to cover for this course. And also the unlimited access to all our course videos. You can pause the video, you can go and do something, come back to it and watch it. And if you want to go 3 days further back, you can also do so. So it's all yours to do. And if you get stuck in that, please contact our backend team. They're a lovely, friendly team. They would be able to support you and make your journey to go smoother along. can we get into learn to communicate? And where we left from the other session, shall we move into this session? Yes, we do. I'll give you a short recap of what we went through. We learned shortly about the I2C, the definition of it, and where it's used, the usage of it, and the different names of I2C. And then a small introduction about where the duty cycle is in terms of the I2C. And then the I2C lines, as you know, the I2C lines requires only two wires to transmit the data, the SCL and the SDA lines. Then it can be operated in 4 different modes: the operation transmitter, master receiver, slave transmitter, and the slave receiver. And then the different I2C bus terminologies that, as you can see, with all these different terminology names with the transmitter and the receiver. And the new thing you learned today in this is the multi-master and the arbitration, where it may be new, but I already explained, so go back to the previous video and you would be able to see that. Then briefly we touched with the protocol, how only the master be able to do the initiation and completion of the message transformation, and then it conveys the transformation in I2C in various formats in the address frame and the data frame, and how it starts with the start condition and how it finishes with the stop condition. And we also learned what the start condition and stop condition is, and also how the packages is sent. And also we briefly touched on the clock speed of different modes. The clock speed mode, we're going to use standard mode in our programming, that's 100 kilohertz max. And the duty cycle and the differences between the I2C and SPI, and then the procedure if you want to read from the slave device and if you want to receive the data from the slave device. These are the procedures you got to follow. And then elaborately about the timing diagram, what every bit represents. So you already are aware, and you know, if not, please do revise the previous session so you'll get a full understanding of this. And then I went into explaining the bit by bit how the message is transferred, and then also showed you the output type. It's connected to Open Drain in I2C STM32F411. And also I showed you where the I2C in terms of the functional block diagram. It is in datasheet. Go to page 15 and you will come across figure 3. That's our functional block diagram for STM32F411. And as you can see, there is 3 I2C1 in this microcontroller, and we concentrating on I2C1 or SM bus. Then we're going to interface this with the ADXL accelerometer. This is a motion sensor where it senses all your motion, and then depends on the output setting, it will get all the data, and you will be able to see that in the logic analyzer using pulse view. So you will be able to see that later. And these are all the steps. The last session we learned and we wrote the code for the I2C initialization to follow. First you have to set the mode, then set the serial clock speed, then the device address configuration, then the enabling the acknowledgement, and then set the rise time. And this should all be done when the peripheral is disabled. And then how to control the serial clock through 2 registers, the control register 2 and the clock control register. A clock control register, you used a small formula to get a value, and you had to load that in the CCR register. And this is the CCR settings, how the clock control is fed to the I2C, and you explained yesterday, and you know or the day before you learned all of this. And this is the example to get the CCR value aside in terms of 16 megahertz and with the 100 kilohertz standard mode. This is the formula you got to follow and calculate. And these are all the steps. I just copied all these steps and showed you line by line how to write this code. And voila! Come on in. Today part 2 continues. So this is a small PCB, as you can see. This is the accelerometer ADXL345. All you have to do is you need to connect the ground pin and the VCC to 5 volts, and we're going to use port B. So the SCL is connected to port B pin 8, and the SDA of this board is connected to PB9. And we also written the CCR macro yesterday with the clock register has defined this command and this calculation. And also we set this I2C T-rise register macro as well with using this registers T-rise between 5 to 0 and the value is 17 for this. And we also used, we will be using CR2 from today's programming. So you need to set bits 5 to 0 to be allowed in this format. So you're going to use that bit 5 to 0. To set the peripheral clock, you need to enable the 4th bit. That's your peripheral enable clock. And the I2C, you need to link that to the peripheral clock. And then the control register. These are all the different macros you will be looking at today. You need to define all the control register 1 macros. You need to give the start address and start condition, sorry, and then the PE, the first bit of the control register 1. This is the one you need to set, and then the CR1 acknowledge. You need to turn the 10th bit, the acknowledge bit, and then the CR1 stop is the 9th bit. So you need to do 8, 9, 10 and 0 bit. So that's the 8th bit as a start bit. So in the master mode, you got to set this as a start condition. And then once that is set, then you need to use the peripheral enable. You need to enable this peripheral. So which will be this P as 1, 0, it's peripheral disabled. You got to set all of this when the peripheral is disabled. And then you need to set the acknowledgement pin, the pin 10, you need to set that. And then the last one is the stop bit, that's here. You need to set this bit 9 as a stop bit. So these are all the I2C control register 1 macro. And likewise, you got the I2C status register as well, the SR1 macro. The first two you have to consider is the TXE bit and the RXNE bit. So that is the bit 6 and 7. Bit 7 is the TXE bit. You need, if you set this to 0, that means data register not empty. If you set this bit as 1, that means the data register is empty. Likewise, if you set the bit, this bit as 0, then that's a data register empty bit. If you set this bit as 1, then that's a data register not empty bit. Then the next two is the SB, the start bit on the master mode, and the address mode you got to set. So these two are the start bit and the address bit. You got to also tell because of the slave address you're going to send. And finally, you need to enable this, the byte transfer. You need to tell the byte, the data bytes are transferred. So for that, you need to use this bit to BTF. So these are all the macros you need to set today at the program SR1, and you will be seeing that line by line in the program. And after this, you also have to set these registers, the SR2 register, which is the busy register, the bit register to define saying whether it's busy or not. So you need to set this bit. And then if we can, then we will also be able to do this interfacing with the ADXL, and the next session you will see the demo, but today we'll start with the program. I just went and copied the relevant information that we need from this data sheet, which I will show you in the program ADSL 345. So you need to first control the power control for power savings and also the data format control. So you got to use 0 cross 2D and 0 cross 31, and first you need to do the device ID. So for that, it's the hex is 0 cross 00. And then you need to give the start address by giving 0 cross 32. That will give you the start address. And we are capturing on 3 different formats of axis. So X axis, Y axis, and Z axis being a motion sensor. So that's why it needs 6 data: X0, X1, Y0, Y1, Z0, Z1. And then first that's the data format is 0 cross 31 you need to send, and then you need to give the device address as 0 cross 53, and then you need to calculate the 4G. The 4G comes as the measurement range, so in this case we're going to consider the 4G measurement. So you need to set the data lines as 0 1 D1 D0, so that's what that. Then you need to reset it by saying reset 0 cross 0 0. Then you need to measure it by this bit D3. It's on the power control, you need to measure that. So this is how you can interface with the ADXL345. First we'll go and learn about I2C byte write, byte read. These are all the steps you need to follow. First you need to wait until the bus is not busy, then generate a start condition, then wait until the start flag is set, then transmit slave address plus write, then wait until the address flag is set, clear the address flag, then send memory address, then wait until the transmitter is empty. So you got to follow until you read data from the data register, which you will learn from this. And then there is two other functions you got to write. You got to write burst write and burst read, and then the interface ADXL345. So I think I'll give you a short break. So when you come back, I will show you how to write line by line in the programming in the IDE. So please go and enjoy that break. When you come back, I'll show you how to write, and then you need to call these functions in the main program, which I will also show how to get that in the main program. Okay, I'll see you back shortly, and I will explain the program in there. Okay, see you back shortly.